There we go. Mic is getting a little loose there. Can't seem to lock in anymore, I guess. Hey there, strangers! It's time for another 2 p.m. PST Twitch stream. I'm your host, Strange Bro Jim, and today we're going to be getting back into Pega. We are going to be working on calculated values today, which is a little odd because I think it was yesterday where it was the ordering of the topics here were slightly different. If I remember correctly, it was fields, views, and then calculated values. So I don't know what happened recently, but it changed it somehow, some way, for some reason. I don't know. Just odd. But um, we were planning on doing calculated values because we didn't really have. I mean, we went over views. Um, and talked about everything kind of concerning views. Um, maybe maybe they looked at my talks about um, the fact that I was talking about hey, you know configured fields isn't even talked about. You're saying hey, in the list option you can mark fields as optional, read only, required, and calculated. I'm like going, okay, that's great. Maybe you can explain what these are prior or sometime during this point, because you're not really addressing what they are, at this time. You know, and I know what they are myself, but I mean, I'm trying to do it from perspective that no one has ever seen them before. So I was like, hey, no one really knows what calculated fields are, at this point, based off of the ordering and so on and so forth. So maybe they saw that and they decided, you know what? You're right. Maybe we should move calculated fields up. Maybe. I don't know. Um, but we're going to be looking at calculated values today. Now, um, I say this pretty much at the very beginning of all of my, YouTube videos and streams with Pega. I'm not an official trainer. I'm not endorsed by Pega at all. I am someone that is just trying to work towards getting their system architect certification. Um, and, maybe even getting the business architect, seeing that it's pretty much closely related with each other. Um, so, sorry, I had something in my teeth. Um, so, had system architect and business architect are very, very similar to each other. Obviously, system architect will go more in depth on the dev app um, versus the business analyst, which will just kind of stick with the or actually dev app, dev studio, and business analyst kind of sticks with the app studio. So um, typically. Um, so we're going to cover, calculated values today. Um, use my, uh, use these videos, use these streams as more of a, um, like as a help maybe, but don't consider it as a full-on training. Okay. If you can do the instructor-led training, do so. Because at least with that, you should have a trained, authorized personnel that will help you learn Pega properly. The trainer that I had was, well, he wasn't the greatest. So I'm trying to correct that mistake. Well, I mean, you know, I tried asking the company that I worked for, hey, can you please, you know, get me back into another training session with a different trainer? But they didn't want to do that, so I'm trying to do it myself. And first attempt on doing that didn't really succeed, so trying again. This time around, I'm doing these streams so that I can try to stay focused on at the task at hand, learn everything that I possibly can, try to get it ingrained in my brain, and then do a lot of uh, like mock tests, quizzes to try to really kind of work on um, what I know and what I don't know. So okay, so let's proceed here. Calculated values, relationships between fields. A calculation expresses a relationship between fields by setting the value of a calculated field based on one or more input fields. For example, an online shopping cart application provides customers a total cost for each item ordered based on unit price, quality ordered, and then calculates a total for all the items ordered. The application then calculates any assessed tax and adds the tax to the order total to calculate the final charge to the customer. Other calculations can determine the value of promotional discounts and frequent shopper points. Calculation occurs whenever users update the value of an input field. Defining a field calculation reduces the chance for error and improves process efficiency by eliminating the need for manual calculation. You can use a calculated field as an input to other calculation, creating a network of dependent calculations. When a user updates the value of a field that serves as a calculation input, the resulting calculation can trigger additional calculations for dependent fields. App Studio allows three types of calculations. Functions, which iterate over items in a list. Expressions calculate a field value by referencing any combination of simple fields, fancy fields, and data relationships. And decision tables use a set of conditions to test property values and return an appropriate response. So, um, although they're showing a lot of information here um, they're not really showing like, okay, so here's the use decision table, use expression, and the sum of, average of, minimum of, and maximum of are, the functions. Okay, they really need to kind of express that because they're not really. I mean, you can imply it, but it's better if they, downright tell you, hey, these are the functions that we are referring to. So check your knowledge with the following interaction. Which two statements identify benefits of using calculated fields? Choose two. Calculations automatically update fields whenever input values change. True. You can do that. Calculations update user form content when the user completes a step. I don't think that's true. Calculated fields are indicated to users with special characters. I don't think that's true either. Calculation reduces mistakes by avoiding the need for manual computation of values. I believe that's true. So, yeah. Um, so One major benefit of calculated fields is automatically updating the field whenever input values change. So you put a value in there and the other values get updated right then and there, right? So Pega platform calculates values perform Pega platform calculated values perform calculations automatically when it reduces the risk of errors, which reduces the risk of errors. So instead of having to type in like 2 times 3 is equal to 6, um, all you have to do is just type in 2, type in 3, and it gives you the answer like right then and there, right? So, or maybe you're getting it from like a database or something along those lines. So it's meant to reduce the possibility of you know, typing the wrong number or something along those lines, doing a misclick, what have you, right? Let's go ahead and do a refresh on this. Let me select the 2 wrong answers here, and so you understand why they say those are wrong. So um, that one and that one. Okay, so Pega platform does not indicate fields with calculations. Right. So I mean, they don't. They're not really explaining it all that well, but they're basically saying, hey, there's no special characters being shown to you in these fields whatsoever. So don't don't feel like you need you're going to be seeing like which fields are calculated fields or whatnot. Ideally, um, if you have a form, you know, um, you know, form being that you have to enter in values in, um, the the fields that are calculated are read only, meaning you can't modify those fields afterwards, or at least one would hope. If you're allowing for that to happen, then well, good luck to your calculations afterwards. But all right, calculations update the value of field whenever input values change, not when the user completes a step. Well, I mean, the values can change when a user completes a step as well. I mean, especially if they're like, hey, I entered in this number, next. So, that could be completing a step. I don't know. But um, you're not you're not updating the form content when you click next though, because you're going on to the next view in this case, right? So um, so when you're completing a step, you're moving on to the next view, which basically, you know, makes you, lose your view of the current form content. So you're not necessarily, you're not updating the form content. Well, I mean, you are, but you're changing it to the next form or next view. So not not really that useful, in that particular case, right? So yeah. Um, so it just reduces mistakes and automatically updates fields. So there you go. All right. So here's their definition. Here's them referencing functions. So it's a little late, but at least they got to it. So pardon me, I need to blow my nose here real quick. Got a little congested right at this moment in time. 1 second. Okay, sorry about that. Okay, so functions. Functions iterate over items in a data relationship and are supported for decimal, currency, and integer field types. Bear that in mind. Okay, decimal, currency, and integer field types. Okay, it does not work for any of the other fields or field types. Okay, not text, not date, not some of the others. Um, it doesn't work on the fancy fields or anything along those lines. Just those three. So bear that in mind. Okay, it's the numerical. It's like the numerical values here, decimal, currency, and integer. I mean, don't get me wrong. Time and date are also numerical. Um, and in some ways, they probably could do functions with that. Um, but it might also be difficult to do that. Um, um, okay, so it might be difficult to handle like a date calculation, for example, um, if it is being processed for if it would be hard to kind of say like this is the stable sum of the date calculation if the date gets changed based on localization. So like say sure, you might have set up the sum of to be handled in United States, for example, but if you go to Europe, then the calculation might be incorrect. So you got to be careful with that, right? So, all right. Uh, App Studio provides four basic functions for use in calculations. Sum of adds all items in the specified property instances. Average of calculates the average value of all specified property instances. Maximum of determines the largest value for all specified property instances. And minimum of determines the smallest value for all specified property instances. So, um, doesn't really provide any like examples here. I mean, they probably explain it more there, but let me do a quick um, example. So, say you have 1, 2, 3, right? So, um, as property instances. Okay, so integers 1, 2, 3. You know, sum of adds all three of those values together, which would give you 6, right? 1 plus 2 plus 3 is equal to 6. Average of would add all three of those, which would give you the 6, but you need the average of that. So you just divide that by 3, or the amount of um, the property instances, and that would give you the average value of 2, right? Maximum of would look at all three of those values and return, what's the most, right? What's the largest value? So that would be 3. So 1, 2, 3. 3 would be the largest, so therefore it would return that. Minimum would be the exact opposite of that. It would return the smallest value. So 1, 2, 3 would return a 1 out of those property instances. So very basic example there, but I'm hoping that you got that rough idea. It's rough, but hopefully you understand. Um, an online retailer needs to calculate a shopping cart total. As customers add items to an order, remove items from an order, or update the quantity of an item on an order, the application must update the total cost. You can use the sum of function to calculate the order total field value. So, I mean, it doesn't, I mean, it does kind of tell you what it does, but at the same time, it doesn't. So, uh, an online retailer wants to configure an application dashboard to analyze customer spending patterns so managers can identify the territories that generate the most and least revenue on a per customer basis. You can create a list of submitted orders filtered by territory. You can then use the average of function to identify the average order value. I mean, again, this doesn't really explain what average of does. It gives you an example of it, but I mean, it doesn't tell you. It doesn't. It doesn't feel like it's really telling you what it is. So, an online retailer needs to allow customers to apply a single promotional discount to an order. Customers submit one or more promotional codes to apply various discounts, such as 20% off the most expensive item or waiving the shopping charge for an order over a specified amount. You can create a promotion discount data reference where each item in the list identifies the promotional code and the discount value. You can then use the maximum of function to determine the most valuable promotional discount to apply to the order. I mean, why would anyone want to use like multiple different promotional discounts? And like, if I was a customer and I can only use one promotional discount, why would I want to apply multiple? If you're giving me the option of applying multiple different promotional discounts, I better have all of those discounts, you know, work. If you're giving me that choice, you better give me all those promotional discounts. Otherwise, you're screwing me over as a customer. You know, um, and that's just bad business. I wouldn't want to come back to you if you're a business and you're saying, you know, oh yeah, you can apply all these discounts, but we're only gonna take one. Wait, what? you know, um, it's coupons, for example. They're they're a discount on an item, right? What happens if you like purchase 20 items, you bring in a coupon for every single one of those items, right? And suddenly you hand the cashier 20 coupons for each one of those items, and they say, okay, well, I can see that this coupon is the best one out of the bunch that will give you the most amount of discounts. So we're just going to take this one coupon and trash the other 19. How are you going to feel about that? Um, so be careful when, yeah, I mean, this is a very weird example, but whatever. Um, again, I don't know if it's really, giving a good example of what it is, but I mean, it's giving an example, but is it really telling you what it's all about? I don't know. Maybe it is. An online retailer needs a promotion where preferred customers receive the lowest cost item from a list of approved free items when placing an order. You can use the minimum of function to identify the lowest cost item in the order and then apply a credit to the order in that amount. All right. That that seems like a relatively, simple, straightforward um, example, and it kind of tells you exactly what it's doing. That one works. So, um, the expressions. Configure an expression to calculate the field value by using any number of simple fields, fancy fields, or data relationship values. In the following example, an online ordering application calculates the cost for each type of item by multiplying the quantity by the unit price. So, um, so here's the thing. Um, Fancy fields don't really have anything that um, are, that are in a sense calculatable, and any number of simple fields. Can expression work on a URL, for example? I don't know. I have a funny feeling that there might be something extra here going on. Um, like, for example, they stated up here, functions are for decimal currency and integer field types, right? That's only a few simple fields. Okay, they're not fancy fields or data relationship values. Um, so what they probably should do in this is really kind of show, how the different fancy fields or the other, non-numerical fields are affected by expressions. Okay. Um, because so far they're showing, you know, integer, um, they're showing decimal times an integer equals currency. Decimal times integers equals currency, and then they're adding both of those currencies up to the total cost, right? Okay. That's still in, you know, there's they're still using these three fields for this one example here, right? Um, but I mean, what about a website? Or let me let's 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 move back to the previous topic here. With the fields. Okay. Um, how do expressions handle date and time, or emails, or phones? Um, you know, what is it doing with attachments or location? They need to address this because, you know, doing integer, decimal, and currency is all well and good. That's understandable. Um, they need to kind of address, how expressions affect, the fancy fields or the non, or uh, the other simple fields that are not, decimal currency or integer. So when you configure an expression, you reference fields by name using the period character. If the field is part of a data relationship, add the property name or list as a prefix. The following example shows a custom calculation that adds the cost field for two data reference fields, team hats and team magnets. So, um, so there's two costs, here. So basically, you know, you have this cost here for team hats and this cost here for team magnets, and you're adding them together for the total cost. Okay, you're adding two currencies together to equal, the total cost of currency, right? But how do you handle an expression when both of the values are URLs? How does that figure? How do you work that? That's something that they should be kind of addressing here a little bit more. Um, so expressions support common operations such as addition, subtraction, multiplication, division, grouping, you're using parentheses, Boolean and, Boolean or. For example, you can configure a calculation to calculate the order tax by multiplying the tax rate by the order total. Tax rate times order total. You can define an expression for any simple field type except email, phone, and pick list. They should have this higher up here. Okay. Okay, they just countered themselves here. Okay. They're saying configure an expression to calculate the field value by using any number of simple fields except email, phone, or pick list. They should have that right there up here. You know, you're basically countering each other with that. For text-based formats, you can configure a calculation to assemble a text string by using a process known as concatenation. For example, an appraisal firm offers to estimate the value of collectible items for customers who submit an item for review. The firm wants to add a comment to the page displaying the item, noting the following information: appraised item name, approximate valuation, appraiser ID, appraiser date. You can define a calculation to assemble the comment by using a combination of field references and static text, where the static text is enclosed with quotation marks. So this is Java right here. You know, this is standard Java concatenation. Okay. Um, you're using a static text plus, you know, a um, a variable, appraiser ID, and you're just basically concatenating both of them together. So appraiser plus 42 plus appraised um, item name frame at the value of 20 bucks on, you know, January 24th. Okay. That's basically what's going on here. Okay. And they're basically putting that in here, which they're not showing that, unfortunately. They really should. Use this lower area here to contain this information, or at least try to mimic it, in some fashion or another. Basically say, hey, excuse me. Um, so um, have the use expression above this or something like that. Give it some semblance of, hey, we're putting it into this field right here. All that. Oh well. Let's see. When evaluating the calculation, the application replaces the reference to each field with the current field value. The calculation creates a string similar to the following example. Appraiser, blah 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 blah, appraised silver platter at a value of 350 US dollars on January 9th, 2019. In the preceding example, the italicized text indicates the value of the reference field. It doesn't automatically italicize the text for you. Okay, if you want it italicized, you have to specify it. But um, as it is, uh, it'd be very. It might be a little difficult to try to italicize, the variables apart from the regular text, the static text. So so yeah, you'd have to you'd have to really kind of um, arrange the display, and even then, you might not be able to use an expression in that particular case. You know, um, you know, if you're trying to show the information, then um, it you might not you want the variables to be italicized. You might not be able to put that into an expression. Maybe. Not 100% sure. Blowing my nose again. Okay, sorry about that. Alright. Decision tables evaluate the value of one or more fields with a set of logical tests to return an appropriate result. For example, to set the interest rate for loans based on the type of loan, the user selects the loan type. The decision table uses the loan type to determine the appropriate interest rate, and the calculation sets the value of the field for rendering in the UI. A decision table must be marked as a relevant record to show up in the calculated field decision table and in the calculated field decision table list. Sorry. To learn more about marking relevant records, see marking a record as relevant. Again, they're moving on to other topics, and it's like, oh gosh. Okay. In the center of the following image, slide the vertical line to compare the configuration a system architect performs in Dev Studio on the left to the configuration a citizen developer performs in App Studio on the right. So here in Dev Studio, this is what you would see in working with a decision table. Um, so it's checking if the mortgage type is adjusted rate mortgage, then it returns a value of 0.029 as a result back. Okay. If the mortgage type happens to be a fixed mortgage, else if it's a fixed mortgage, it'll return a 0.031. If it's neither of these two, if it's not an adjustable rate mortgage or a fixed mortgage, then they want you to return a 0.035. Okay. It will only return one of these values. Okay. For anybody that's kind of curious about this. Okay. Um, so um, now be careful with this because you want to make sure that the the string is is the same. Okay. You want to make sure that it the fixed mortgage is a fixed mortgage in your mortgage type. Okay. You want it spelled out, in the exact same way. Because what they're doing here is that they're doing a comparison. Okay. They're checking to see whether or not, the mortgage type that's being brought in is the exact, is letter for letter, symbol by symbol, the exact same. Okay. If it's not, then it's going to basically say, hey, if this is this, then that's true. So therefore, you have to move on to, returning the value. If it's false, meaning like, hey, you're missing A in adjustable, in your mortgage type. So therefore, it's not an adjustable rate mortgage. So it's false. So you have to move on to else if. Okay, so you want to make sure that your lettering here is correct. Okay, if you miss, if it's not exactly the same, then the comparison is going to be incorrect, and therefore it's going to fail. So it's basically going to say this is false. This comparison is false. So you have to move on to the next one. So you have to make sure that you get um, you have to make sure that the comparison is correct. It's the same. If you mess up in some small way, like maybe you didn't even include the dash or something like that in your mortgage type, then you're screwing up. You're messing up your decision table here. So just bear that in mind, when you're doing this. So now over here in the App Studio, they're basically saying, the interest rate that you're going to be getting back is a percentage. The ID is set to interest rate here. Okay. Um, this is, being done from a, we're adding a new field here. Okay. Um, we use the decision table, an existing decision table, and the interest rate table, you know, to do our calculation here. Now, here's the thing. Um, the sure this is what the um, this is what the App Studio does, but if you don't have your programmer, your system architect, if they did not build this interest rate table for you, you know, then there's not going to be anything here. There's no existing decision table that you can reference here. Okay, so you need this first before you can use it here. So bear that in mind. Okay, because if you're trying to search for an existing decision table, if it's not been created yet, then it's not going to find anything. Okay, so there's no like default interest rate table out there in the decision table land. Okay, so don't expect to kind of do this and expect to get the results that you see here. It's just not going to happen. You're not going to see it. It's not possible. Okay, so just bear that in mind. You know, um, if you're kind of looking at this from a um, business standpoint. Okay, so if you're coming at this from the App Studio, be careful with this. Okay, make sure that that decision table has been created first before you do this. Calculation networks. To identify the relationships between fields, Pega platform establishes and updates a network of calculations for an application. When you define the field calculation, Pega platform adds that calculation to the calculation network. This calculation network allows Pega platform to update all relevant fields whenever a value changes. For example, in the shopping cart, changing item quantity can push an update through several dependent calculated fields. In the following image, click the plus icons to see the functions that trigger the shopping cart calculations. So, you know, line total calculation. Users add an item to the list or update the quantity of an item already in the list. Pega platform calculates the line total as unit price times quantity. So, unit price times quantity, or unit price times quantity is equal to the line total. total order calculation. The updated line total triggers a calculation to the updated order total using the sum of function to add each line total in the list of items. So it adds both of these together, whenever there's a change in quantity. Okay. It then does the, calculation here for the tax. The updated order total triggers a calculation to update the tax applied to the order as a value of tax rate times order total. So um, we're not changing the tax rate. Tax rate stays the same unless, of course, there's like maybe you have a like specified tax amount for um, like okay, bear this in mind. Okay, maybe you have some items here that are exempt from taxes, right? Like that could happen. You might have something that's um, um, like medical or something. I'm just saying, like if there's something that is exempt from any kind of sales tax, whatever you might say, okay, then you want to make sure that your line total here, okay, either is not added to the order total until like afterwards, okay. Like say the team logo hat is tax exempt for some reason, right? So you'd want to have the ordering here, the calculations being that you do the magnet, you add it to order total, you do the tax to that order total, and then you add in the next line total to get your total cost, right? So just bear that in mind. The updated tax amount triggers a calculation to update the total tax as a value of tax plus order total. So, you know, there's your order total plus the tax is equal to your total. Okay. Check your knowledge with the following interaction. What two items describe the function of a calculated network? Choose two. Identify the relationships between fields. No. Update all relevant fields whenever value changes. Yes. Determine the calculation function for a group of fields. Wait, hold on. What two items describe the function of a calculation network? It shouldn't be identifying the relationship between fields. Alarms going off. Determine the calculation function for a group of fields. I don't know if you really need that. Automatically configure customer calculations. I think that's the answer there. Okay, apparently not. I'm not sure. I, you know, oh, I guess it is identify a relationship between fields. That's weird. Weird phrasing on that. Because, I mean, your expression is kind of determining the relationship, right? The network isn't doesn't really care about your expression. It might, notify that, hey, you need to, reset and redo, the expression, but does it really care about what's contained within an expression? Doesn't seem right. So apparently identify the relationship between fields and update all relevant fields whenever value changes. Those are the two correct answers there. Okay, hold on. Let's redo that, and let's get both of the wrong answers there and see what exactly they say again. Um, sure, you're not really explaining why though on those answer explanations there. So, um, calculation networks do not determine calculation functions, which is correct. It doesn't. It doesn't need to. It's not the one selecting, which function to use. So, you don't need to worry about that. Um, then don't configure custom calculations, whatever that might mean. Um, you know, what exactly do you mean by custom calculations? Um, the following example shows a custom calculation adds a cost field for two data reference fields. Okay, sure. So they don't configure custom calculations. Okay. I mean, that's true. I mean, you're not um, the network isn't telling it how to set up the expression and how to, what values you're setting in there, but, how's it identifying the relationship between fields though? I mean, because, you're doing the identifying by fields here in the expression, right? Unless I'm missing something. Your fields are different here, and therefore, or you're doing the calculations here, so you know, um, your expressions are doing the, evaluating the fields. Otherwise, it wouldn't be able to understand, how to handle, you know, even, calculating out these, the simple field types, right? So what do they mean by identifying the relationships between fields? What does that have anything to do with this? Find a field calculation. Pega platform adds that calculation to the calculation network. This calculation network allows Pega platform to update all relevant fields whenever a value changes. For example, in a shopping cart, changing item quantity can push an update through several dependent calculated fields. Maybe that's it. Maybe it's a matter of it's it's setting up the um, whenever you're adding a field in and you're saying this is, this needs to be added into the calculation network, it then says, okay, I'll use this field for the calculation network, and therefore, I won't need to worry about, adding in like this field for the calculation network. So, how it goes about doing that though, how does it handle that automatically? Might be kind of behind the scenes, okay? Because I mean, when you're doing the expression here, you know, it might understand that, hey, when you modify the cost for one, you're changing the total cost. So therefore, that needs to be put into the, um, it needs to be put into the calculation network. Okay, that this value affects this this other value. The showing of the values in there. So possibly, I don't know. Okay, we're going over. Um, so we'll have to cut it off here at this particular moment in time. So we are done with fields, calculated values, and views on this. So next and tomorrow we're going to be going over the module quiz and then moving on to the next portion of the low code app builder, which I believe is a challenge. So verify that. We're doing the capturing and presenting data. So yes, we're going to move on to adding fields to views in the next one. With it being like 5 minutes and 20 minutes, I would suspect that would be able to handle both tomorrow, but we'll see. It depends on how their module quiz is, because I know that when I did the data model quiz, that one took a lot longer. That took the full hour. So to kind of go through that, because I was struggling with the information being done there. So now I do appreciate the fact that they did, switch the ordering around in this module here to show that, hey, views are, um well, they didn't like fully address the whole optional, read only, required, and calculated. At least they, you know, kind of showed more about what calculated is. So, but I mean, um, but you're not really stating, what exactly, what happens with these, optional, read only, and required, you know. Um, what happens if you select one for required and the user tries to move past it, that particular view. You need to state that, you know, that kind of thing. So, as a programmer, I know what these are all about, kind of thing. So, um, but yeah, this um, that should be kind of addressed a little bit more, I think. Uh, they're not really they're not really talking about it all that much, and I feel that that's a disservice. But all right, we'll move on. All right, so that's gonna be it for today's video, especially for those of you that are watching this on YouTube. Um, I'm going to go ahead and close this down. You know, for those of you that are watching on YouTube, you know, um, if you like it, like, comment, subscribe, bell notification, for more of these Pega videos that are going to be coming out. Um, check out the other playlists that I have, the other, coding streams that I did, as well as, all the Let's Plays. You know, I do both, so, or at least I did both. In past tense for the coding, at least. Okay, but that's it uh, for this particular session. For those of you that are still here on Twitch, second, let me go ahead and stop the recording now.